less than or equal to operator, then specify the delay or the event to this, to the right hand side expression. Now this is your right hand side expression. Okay. So the less than or equal to operator is used to specify the what blocking, non-blocking statements. So we know that procedural assignments are two, blocking and non-blocking. So in
क्या
non-blocking
बोलना मैं?
assignment statement, how it is scheduling? How it is scheduling? Non-blocking statements allows the scheduling of the assignments without blocking of the execution. What is the meaning of this is?
ना बच्चा देखता है ना कुछ देखता है।
All statements are running what? Parallel. The same time. Parallel execution, concurrent execution. It is not blocking. If one statement is executing, like in your blocking statement, another statement will be blocked. Correct. So once the preceding block is executed, then only it is go to the next block. But in the case of non-blocking, it is allowing scheduling of assignment without blocking the execution of the statement that follows within the what? Procedural blocks. You understand, if you are using multiple procedural blocks, that block, it will not block only the what? Only the particular procedural block what you are using. If there are multiple blocks are there, it is not no link to what? First block to the next block. Okay. So this will be this will without blocking the execution of the statement that follows within the procedural block. Are you understand? It means if I write the example to this, now coming to the example of same one, we are writing initial, correct? Initial begin. So we are writing like this: A is equal to hash 5 of B plus C. B is equal to hash 5 of C plus C. What statement I am writing here in initial block is? What operator I am using here? Blocking operator. Blocking, how this blocking operator will be scheduled? First this will be executed. Once this is updated, then it is going to what? B will be executed. This is a blocking. Non-blocking means what I need to do? Less than or equal. So all these are what? Concurrently executing. It is not blocking. When this is executing, this is not blocking the second step. That is the meaning. It is scheduling like that. All are concurrently executing. Are you understanding? That is the meaning of this statement. So the assignment to the target gets scheduled for the end of the simulation of the cycle. End of the simulation of the cycle. At the end of the process blocks. Means how this will be executed. Let me put the end here for this procedural statement. How this will be executed? Concurrently means what? This also start scheduling the execution of what? T is equal to 5. So this is also start executing at what time? T is equal to 5. So how this will be blocking, non-blocking statement will be executed. So first we will do the read operation. Read operation. What is the read operation is? First right hand side will be evaluated. Means that is reading the input to the internally temporary variables. It will store in the temporary variables. At the end of the timestamp of this procedural blocks, that will be assigning to the what? Right hand side variables. Two operations here, read operation and what operation? Write operation. The way it is scheduling for the blocking and non-blocking is in different manner. The blocking means first statement executes, and it goes to the next statement, then it goes to the next statement. The way you are specifying the delays to the statements. Okay. For in the non-blocking statement, all are concurrently executed. Concurrently means what? This is also scheduled at the same time. This is also scheduled at the what? Same time. What happens here? Right hand side will be first evaluated. That will be read into the temporary variables inside the simulator. Did you understand? So there is certain advantage of blocking and non-blocking. If you talk about there is advantage in blocking, some disadvantage in the blocking. There is advantages in the non-blocking and disadvantage in the non-blocking. How this will be executed is first B plus C will be evaluated at what time stamp? 5. This also 5. So this will be evaluated. This will be stored into the what? Temporary variables inside the simulator. Did you understand? Now this is acting as now it is in read mode operation. Now once it is getting evaluated, the expression that will be reading into what? Temporary variables. Whenever this each blocker come to the termination, correct? And before during termination time, whatever the values are stored in your internal temporary variables, that will be assigning into what? Right hand side. Or then it is a write operation will happen. Did you understand? The way the scheduling is different in the non-blocking. This will be executed concurrently. Those values are stored into the temporary variable inside the simulator. Correct. That will be assigning to the left hand side at the end of the timestamp. Did you understand? Now you can see there is advantage of doing this when you are especially talking about the sequential logic circuits. Non-blocking is very good. Blocking is not that much of good for synthesis purpose. Are you clear? If you look at the disadvantage of this non-blocking means, so to store this, whenever the right hand side is evaluated, to store this in the temporary variable, you need extra memory. Is it clear? You are burdening the what? Simulator. Since we are asking to what? Create the temporary variables that will be assigning to the what? Temporary variable. Then this read operation is happening. Then we should do what? Write operation. That should be writing to the left hand side when the end of the timestamp. So this consumes the extra memory, non-blocking statement. But the way it is scheduled in the blocking statement is nothing but it is sequential, it is executed. Are you understanding? So this is a non-blocking statement. So you see, non-blocking statement, the assignment to the target gets scheduled for the what? End of the simulation of the cycle. End of the simulation of the cycle. At the end of the what? End of the procedural block. Your initial block and always block is what? When it is ending, the initial block and always block. At the end of the simulation time, we are scheduling to assigning the value from your what variable? Temporary variable to your left hand scenario. Two operations will be happening in the blocking model, non-blocking model. What is operation is? Read operation, then write operation. So when the write operation will be done? At the end of the simulation. Are you understanding? Is it clear? The assignment subsequent to the instruction under consideration are not blocked by the what? Assignments. Means if there are two subsequent statements are there, is there blocking when it is executing? That is the definition of this point. The statement subsequent to the instruction under the consideration are not blocked by the what? Assignments. All are concurrently executing. See, in simple words, I can illustrate this is nothing but this also start at time t is equal to 5. This also start at time t is equal to 5. Okay. First, the right hand side will be evaluated. That will be temporarily stored in the temporary variables inside the simulator. So when it is coming to the end of this simulation at T5, end of this simulation, that locally stored, temporarily stored in the variable will be assigning to the what? Left hand side variables. So basically this consumes extra memory, not blocking. So a blocking consumes less memory. Sorry, this consumes more memory, non-blocking. Blocking consumes the less memory. So because it is creating the what? Temporary variables. Then that will be assigning to the left hand side variables. Two operations, read mode and the write operation. This is how you are scheduling the what? Non-blocking operations. So allows concurrent procedural assignment suitable for the what? Sequential. So non-blocking assignments means concurrent procedural assignment. Non-blocking I can also call it as what? What is another name I can call to the non-blocking assignment? Concurrent procedural assignment. Sequential procedural assignment I can call it as what? Blocking. Concurrent procedural assignment I can call it as what? Non-blocking. I said blocking will be recommended for what logic circuits? Combination logic. Non-blocking will be representing for what? Sequential logic. After taking few examples, we'll understand. Is it clear? How this will be scheduled, non-blocking will be scheduled, how this will be executed, correct? Concurrent. Now let us take example to this. Okay. So this is a recommended style for the modeling for the sequential logic circuit. You can see this example. What operator I'm using? Less than or equal to operator. I think same example we did earlier. Correct. In that case, what operator we are using? Equal to operator. So here, several rigid type variables can be assigned synchronously under the control of the common clock. So when you can use the non-blocking statement is, whenever your clock rising edge comes, your input will be synchronizing. Whatever the input or output you are writing, that should be synchronizing to the clock. Such cases you can prefer what modeling technique? Non-blocking modeling technique. Non-blocking modeling technique. Now you can see this example using integer a, b, c. Begin now. And second initial begin what I'm doing. I'm writing the expressions. What expressions these are? Non-blocking expressions. I'm using what operator? Less than or equal to non-blocking operator. How the way it is scheduling and executing. How the way they are scheduled and executing here. Concurrent execution is equal to 10, B is equal to 20, C is equal to what? 15. Correct. Now coming to A becomes 35. Correct. What is the D values? Plus 5. Now A becomes what? 35. So this will be stored at what time? Where this will be stored? At temporary variables. Temporary variables, the simulator. And this will be executed at what time? Now what is the B value is? What is B is? Whether it is 35 plus 5 or it will be 10 plus 5. Why it is 10 plus 5? Concurrent expression. Did you understand this also? It is not going to take this value. Correct? This is taking the what? Previous value. Initial value. What is initial values? 10. What is 10 plus 5 is nothing but 15. Now B becomes 15. Correct? What about the C value? A minus B I am using it. So A minus B means what? 10 minus 20, that becomes what? Minus. Are you understanding the non-blocking operations here? All are executing at what time? Time 5. All are executing at time T5. This will be evaluated. That will be read into the local variables. Means temporary variables in the simulator. That will be writing at what time? At the end of this timestamp 5. Did you understand? At the end of this procedural block. Are you understanding? See, the way it is behaving for the blocking and non-blocking is different. You will understand it. You won't give the same result, right? It gives the what? Different results. It is a designer point of view that when we should use the blocking statement, when you should use the non-blocking statement. But recommending style of doing the blocking statement and non-blocking is, blocking is always you can prefer for what? Combination. And then non-blocking is using for what? Sequence. You understand? Now we'll see why blocking is using for combinational and non-blocking using for the sequential part. I think this example is clear. So all the right hand side of the expressions are evaluated together, correct? All are evaluated together. And what is time stamp? Time t is equal to 5 based upon the what? The previous values. Based upon the previous values of what? A, B, C. A, B, C are they assigned together at the time what? 5. How basically it is? What operation is done in the non-blocking operation? It is done with what? Read operation and write operation. At time t is equal to 0, t is equal to 5, all are evaluated. That will be stored in the temporary variables. That we call read operation. That will be right into the left hand side variables at the end of the time step. You understand? Now, can you see this example? What is this example is? Always at the rate of what we are writing the event. Always at the positive edge of the clock. Begin. What statements I am writing it? Non-blocking statement. So what is this? How this will be executed? Whenever the rising edge comes, correct? Positive edge comes. Positive edge. This is a positive edge. This is a positive edge. Correct? So what expression we are writing here? D AND operation, bitwise operation of C, A XOR operation of D, and A OR operation of B. So all these are executing at one time. So all the assignment takes place. All the assignments, whatever the assignments I'm writing here, is a what assignment? Non-blocking assignment. So all the assignment takes place synchronously at what? At the positive edge of the. They synchronize with what? Positive edge of the clock. The way we are specifying the delay to this, it will be scheduled. So recommended style for modeling the synchronous circuits, where the assignments takes place in the synchronization with the clock. Such cases you can use what blocking statement? Non-blocking. When you are scheduling or when you are synchronizing this with the positive edge of the clock, it is recommended to use what modeling technique? Non-blocking technique. So this is all these are executed in what time? At t is equal to what? 0. At t is equal to 0, right hand side should be what? Evaluated. That will be stored what where? Temporary to the temporary variables. And then that will be assigned to the left hand side. Now let us see this example. What is this example is? Now let us try to swap the two variables in the blocking and the non-blocking. We'll see what is the effect of the blocking and the non-blocking. So I'm trying to swap in the two variables. A is a one variable and B is the one variable. How to swap the variable? How to swap the variable? A is equal to B, then B is equal to A. If A is equal to 10, that will be assigning to the B. If B is equal to 20, 20 is assigning to the A. This is what I'm swapping the variables. If I'm taking the example of swapping of two variables, now let us see this, what statements I'm thinking, blocking or non-blocking statement. Blocking statement. How many procedural blocks I'm using? 2. This is a one always block. This always block at the positive edge of the clock, what I'm doing? I'm assigning to what? B. Another procedural block always at the positive edge of the clock, what I'm doing? Assigning B is equal to what? A. This is nothing but swapping operation. A is assigning to B at what edge? Positive edge. Correct. B is assigning to A. Correct. At what edge? Positive edge. Now let us take A is equal to 10. B is equal to 20. Correct. Since I'm using two always blocks, both are start executing concurrently. Did you understand? This is scheduled at what time? T is equal to 0. This is scheduled at what time? T is equal to 0. But here what happens, it is depending upon, maybe this will be start first, or this will be start first, or vice versa. Because both are scheduled at what time? T is equal to 0. Concurrently it is executing. Correct. Suppose if this is started here, what is the A value is equal to? A value becomes 10. Correct. A value becomes 10. So how this blocking statement will be executed? Sequentially, right? If you see, either A is equal to B will be executed before B is equal to A, or vice versa. Means, if I am starting from here, A is equal to B means what? Now A becomes what? 10. After this only, this will be executed. Blocking statement I am using. Now what is the B value it gets? B is equal to what? Assigning the A value, right? B is equal to 10. After this, now A becomes 10 now. Sorry, A is equal to B I am doing, right? Now A, what is the value of A is nothing but 20. A value is 20. Now what I am doing here? Swapping I am doing. Now what is the A value here now? 20, right? See, I am doing A is equal to B, A is equal to 10 and B is equal to 20. Once this statement executes, what is the value of A is? What is the value of A? A is equal to B I am doing. What is the B value is? 20. Now what is the after this execution, scheduling, what is the A value is? 20. Correct. Then how this blocking statement will execute? Now it comes here. Now what is the value of A is? 20. Now 20 is assigning to what? B. Is it values are swapped here? Is it swapped? Means swapping means what? A should get 20, B should get what? 10. Now I need to swap the value. If I go with the blocking, whether I can able to swap the two variables. So this is we call it as racing problem, race condition. If I'm trying to swap the two numbers using blocking nature, what happens here? There is a problem called as a racing problem. Now imagine same thing using what? Non-blocking. How this will be scheduled? See, this will be executed at the time t is equal to 0. Correct? At time t is equal to 0, B is assigning to what? A. Correct? Since these two are concurrently executing, right? Now this right hand side will be evaluated, that will be stored in the temporary, that will be assigned to the or writing to the left hand side at the end of the time step. Now for this swapping of the two variables, I can able to swap the variables going with what blocking? Non-blocking. In the non-blocking, let us take this is A is equal to 10, B is equal to 20. How this non-blocking will be scheduled? These also start at time t is equal to 0. These also start at time t is equal to 0. These are two procedural blocks will start concurrently executing. Correct. Now what happens in this case? A is equal to 20, right hand side will be evaluated. Then it will go to the read mode means what? This will be read to the what? Temporary variable. Are you clear? That will be assigned to the what? At the end of the time step. Now A will be assigning to the 20, right? And then what is this is nothing. This also concurrently. Now A value is 10. That will be evaluated. That will be what? Temporary variable. That will be assigned to the left hand side at the end of the time step. So that swapping will be happen in what? Non-blocking. The swapping is happening if there is a scenario that whenever you are swapping, one case where you need to avoid the blocking statement is nothing but when you want to swap the value, if you go with the blocking statements, you'll be encountered with what? Racing condition. So that when there is a situation in your design, when you want to swapping the values, you should go with what? Blocking, non-blocking. This is one test case. How to avoid the blocking, or what case you can avoid the blocking assignments. Are you understand this one? Is it clear? See, in this case, there are two always blocks out there. Maybe this will start first and this will start first. Because two multiple statements, both are starting at t is equal to 0. First it will execute A is equal to B will be executed before what? B is equal to A, or it may be vice versa. Are you understand? But this will be starting at what time? At time t is equal to 0. So depending upon the simulator, this will be. Okay, we can't exactly tell that this is first and this. Yeah, hello?
Yeah, in blocking swapping, sir. Always supposed to A equal to B means A value is the 20, right?
So A is equal to 20.
So in second condition, B equal to A means the A value is 10, right?
How A value will be 10? This is sequential, how blocking.
In sequential, procedure blocks not blocked, sir. Only procedure statements only blocking, right? In blocking assignment, procedure blocks are not blocked, right?
Now let us make a clarification of this. Let us take this A is equal to B will be executed first. There are two multiple blocks I am using, right? Now A is equal to B I am using. This is executed. This always block is executed. Now A is assigning to what now? 20. Correct?
20.
Now coming to this always block. I am using what? What is this? Is nothing but blocking operator.
Blocking, okay.
Now B is equal to A. Now this blocking will execute what? Sequential blocks, right? Now it is not going the initial value which is assigning to the A is equal to 10. this A will take what is the value assigning before this. Before this, what it is assigning to the A is nothing but.
Sir,
It
అంటే
will
నేను
take to the B.
స్టార్టింగ్ లో మీకు చెప్పారు కదా సార్, లైక్ ఓన్లీ ప్రొసీజర్ స్టేట్మెంట్స్ నే, సీక్వెన్స్ స్టేట్మెంట్స్ నే బ్లాక్ చేస్తుంది, బ్లాక్స్ ని బ్లాక్ చేయదని. సో ఈ రెండు బ్లాక్స్ ఎట్ ఏ టైం ఒకే టైంలో రన్ అవుతాయి కాబట్టి ఏ వాల్యూ కూడా ఐ మీన్ బి వాల్యూ 10 అవుతుంది అనుకున్నాను సార్.
So you are talking about this always. If I am writing A is equal to B, B is equal to A. If this is a schedule, this will be blocked when you are using the what operator, blocking operator.
ఎస్ సార్.
This is our schedule. But here I am writing two always blocks here, correct? Two always blocks. Both are start executing at time t is equal to 0. Okay. Maybe
Yes, sir.
A is equal to B will execute before B is equal to A, or B is equal to A before A is equal to, vice versa can happen here. Suppose if it is started, this is depending upon the simulator, which one it is start executing, but both are executing at time t is equal to 0. So in this case, what happens, if this is executed, suppose I'm starting here, this is executed, now B value will be assigning to what? 20. B
Yes,
is
sir.
nothing but 20. B 20 is assigned to the A. Now A becomes 20. Now since I'm using blocking statement here, then it comes here. This always block. In this always blocks, it is not going to take the values of earlier what it was the initial value, A is equal to 10. This will take what? This block is executed here. You understand? Now A is assigning 20. 20 will be assigning to the B, so that values are not sharply. Both the registers will not get the same value of A or B in this case. So this problem, basically we call it as a racing condition. You do understand now?
Okay, sir, but I'm not getting a full clarity. Actually, what my thinking is, at time t equal to 0, both values assigned at the same time only. I'm thinking.
No. Here I'm using multiple blocks, right? Both are start executing at t is equal to 0, but the way it is start executing will depending upon the simulator implementation. Maybe first this will start or this will start, or this will start or this will start. If I'm start analyze from here, now B value is assigning to the A.
Okay, sir.
Since
Post
I'm
I have.
blocking
Okay,
it.
sir. Post always back it executed. So A value is 20, B value is 10 only.
How B value?
A
I'm
value-
doing any expression there.
A
A
value
value
is
is
20,
equal
B value
to
also 20, right?
B value is also 20. Correct.
So in second,
On this
for
execution.
example, if post second always back executed post, so B value is 20, A value is 10 only.
Correct. B value is equal to 20, A value is equal to 10. In that case, B value is equal to 20, A value is equal to 10.
Sir, what if first equation is delayed, sir?
First equation. I'm not getting your point. Can you repeat again? What if the first equation?
In first block there is a delay, means second will execute first or second, like in a series it will execute, sir.
Then you are scheduling based upon the time. Based upon the time you are scheduling. If you give hash, suppose hash 5, then this will be start executing at time t is equal to 0. Then this will be executing at time t is equal to 5. Based upon the schedule, what your time you are scheduling for this block. Not the point. Okay, let us continue with this. See, this non-blocking, coming to this non-blocking. See, either B is less than or equal to A will be scheduled, A is less than or equal to B, or this will be scheduled before this, vice versa. It is based upon simulator to simulator dependency. Okay, but these two are executing at what time? Time t is equal to 0. At time t is equal to 0, how this will be executed? Right hand side will be evaluated. that will be stored in temporary variables. That is a read operation. That is reading to the temporary variables. At the end of this time t is equal to 0, that will be assigning to what? Left hand side variable. So that swapping can be done here. It is reading concurrently, it is to our same time, it is executing. Now B value is 20 and A value is nothing but what? 10. So now B is reading at what? At the end of this time instance, A is 20 now. Now B becomes what? 10. So in this case, swapping is happened. In this case, no swapping. So that problem we call it as what? Race condition. So where to avoid the blocking statement? No. With this example, where to avoid the blocking statements? In your suppose your procedural assignment statements are two, blocking and non-blocking. Okay. So if you are a good designer, that when to avoid the blocking statement with this example? When there is a values are swapping, A and B values are swapping. In that case, what you need to do? You want to avoid the blocking statements. Go to the non-blocking statements. So one use of the non-blocking is what? You can swap the values. If I want to swap the values in the blocking statement, what happens? I'll be getting a racing. Values are not swapped. That problem we call it racing problem. So in this non-blocking, the variables are correctly swapped in the non-blocking. So all RHS variables are read first. This is what I said, correct? This right hand side will be evaluated. That will be reading into what? Temporary variables. And assigned to the LHS variable at the what? What I'm writing here is positive edge of the clock. The positive edge of the clock, it is going to write at to the what? Your left hand side variables. Basically, two operations will be done when you're going with what model? Non-blocking. What is the model? What is operation is? Read operation and write operation. But all are executed concurrently. Did you understand this example? Okay. What is the racing condition, racing problem? Now you can see this. Suppose I want to achieve the swapping operation only the blocking. Then how to achieve this? Now I want to achieve the swapping operation using what? Blocking only. What I want to do? What I want to do? I want to need a temporary variables to store. Correct. How to do means, so trying to swap using what? Blocking. You know that if I go with non-blocking, I can swap the values. If I want to do the swap the values using blocking assignment, I have to, this is the example. You can see always at the rate positive edge of the clock. A is equal to B, B is equal to E. So both A and B will get the value previously stored. Now let us take A value. B value is what? 20 initially. Now when this is scheduled at T, what is the A value is? What is A value is? 20. Correct. This also at what time it is executing? At time, both are scheduled at what time? Time T0. A is 20. Correct. Now B what? 20. Whether swapping is done here? No, I'm writing a swapping expression here. A is equal to B or A is equal to A. Swapping is not done here. So both A and B will be getting value previously which is stored in B. Now A also 20. This B also get 20. It is getting the value previously it is stored in what? B value. Correct. Did you understand this? Swapping is not done here. Now I want to do the swapping using what operator? Blocking operator. How to do? Then I should use the temporary variables. Correct. So this is a way we are for what blocking statement. I'm using what operator? Blocking operator. First I'm declaring temporary variable TA. We are assigning what? A is equal to T. If I'm taking A is equal to 10, B is equal to 20. Correct. How it is executing? This is a blocking statement. Blocking statement will be executed what? It is executed this statement, this will be blocks the what? Other statements. This block will be executed only when the preceding execute. Correct. If A is equal to 10, first what happens here? TA is equal to 10. Now TA gets what? 10. After this will be executed. What is this? Is nothing but TP is equal to 20. Now what I am doing? A is equal to TB. What is TB is? Now A is 20. What is B is nothing but T. What is TA is nothing but 10. Now swapping is done here. We are done using template. Using non-blocking. Understand difference. Suppose if at all I want to do swapping using what? Blocking itself, then I should declare what? But when I go with this modeling, non-blocking, how it is working? Two mode of operations, read mode and write mode. Read mode will evaluate and then stores into the temporary variable of the simulation. That will be right into the left hand side at the end of the simulation. What it is scheduled. Did you understand? So when to use the blocking and when to use the non-blocking. This is one thing. Whenever there is a swapping of the variables, you can avoid what? Blocking. You can go to what? Non-blocking state. Now let us go to the next. Here see, correctly the swapping will occur. So we need to do what? Two temporary variables. Swapping is done using blocking itself, using what? Using temporary variables. Correct? Is it clear this? Now let us go to the next example. Can you see the simulation of this example? Simulation of this example. This is a design file for the non-blocking assignment. This is a test bench to this. Okay, so I'm monitoring this. So since I'm writing here positive edge of the clock as an event here, so I need a clock. Clock is generated using forever statement. First I am initializing clock to 0. Forever, how it is generating the clock? T on should be 5 and T off should be 5. So forever is working like what? It is a continuously it is generating the forever loop is nothing but continuous loop. It is similar to like your always.
That's it. Other for a completed space counter in the hall. Did you complete it? No, sir. உங்க டீம் வந்து எங்க அவங்களாம் வரல அவங்களாம் கம்ப்ளீட் பண்ண completed and in the WhatsApp కి ఆఫ్లైన్ కానీ రేపు వస్తే వాళ్ళని కేక్ పంపించి వాళ్ళకి పంపించారు. You have to come to not move. If you move, I will move.
Okay, let us understand this non-blocking assignment. So can you see how this will be executed non-blocking assignment? So we're writing integer a, b, c, d, raise the clock. It's always at the positive edge of the clock. So what statement we are using? Non-blocking statement. Correct, non-blocking statement. So this is scheduled at what time? The clock is generated at what? 5. Correct. This should be 5. This should be 5. Total time period is nothing but what? 10. This is a positive edge. Next positive edge comes here. The next positive edge comes. This is at 15. This is at what? 20. Now can you see what is the simulation output of this program for the non-blocking? What is the non-blocking simulation output of this is? So A, I am doing what? B place C. D is nothing but what? A minus 3, B is nothing but D, C is C plus, non-blocking operation. So what is the result of this program? At time 5, what is at time 5? A is equal to 35, okay. At the time 5 or at time 20 it is? Same time? This what? Is it 35 minus 3 or 30 minus 3? This is nothing but 27. What about this is? D is 5. 5 plus 10 means 15. What about this? C plus 1 is nothing but what? 16. At what? Whenever rising edge. And next rising edge, how this will be executed? So always at the positive edge of the clock I am writing it. Now at time it is 5. What is next time it is changing the rising edge comes at? Now this is at time t is equal to 5, rising edge. Next rising edge comes at what? 15. Now what is the A value? Whether this will take this value or initial value which is assigned to this. If it is initial value, it should be the same, right? 35, 27, 15 and 16. How this will be executed? No. A is equal to next rising edge comes, and what I am doing is A plus C. B plus C. B is nothing but what? 15. B is nothing but 15. Plus C is nothing but 16. Means what? 31. Correct. So you can see at time t is equal to 0. These are the values where it's less. Now this is the code I am writing it. Now when the 15, the rising edge comes. Rising edge comes at what time? 5. 5, what I am doing is, all of these are concurrently executed. Correct? When it is concurrently executed, the A value is. B is 20 plus 15 means what? 30. What is the D is? How this will be scheduled? D is 5. 5 minus what? So D is A minus 3. A minus 3 means what? 30 minus 3 is nothing but 27. D becomes 27. What is B is? D plus 10. D is 5 plus 10 means what? 15. D is 15. What is the next? C is nothing but C plus 1 means what? 16. 16. But if I remove this less than, now this will be executed. Then that becomes a blocking state. Correct? At t is equal to 5, A will be assigned. Again, whenever next rising edge comes, at t is equal to 15, D value comes. Again, next 25, then B will be updated. Then next 35, C will be updated. Sequential blocks. Okay, blocking execution. So this is an example for what? Non-blocking. At next to the rising edge comes at where? 15. At 15, what happens? At 15, B plus C. A is nothing but B plus C. Now B is what? 15. C is nothing but what? 16. 15 plus 16 means what? 30. At the same time, what is D is nothing but? E is 35. 35 minus 3 means 30. D plus 10. So D is 27. 27 plus 1 is 10 is 37. See, these two examples for blocking and non-blocking, you should clearly understand. You can see for the blocking how this will be executed here. Correct. Once the subsequent preceding the block execute only, then the next block executes. This is example for what? Blocking. I think same example I'm taking there also. Correct. Did you understand? This is a blocking. This is for what? Non-blocking. Here what happens at C, what is C? Nothing but C plus 1. C 16 plus 1 means what? 17. Are you understanding this? How blocking statements will be executed and non-blocking statements will be executed. Is it clear this example? You can, anyway I have given the code here. You can take this file, write the test bench and you monitor and you display the output at the console and check how this blocking and non-blocking will be executed. Is clear this? When the next rising edge comes, what happens? Now this will take this values, APD, a time 50 value, then it is scheduling according to this value. Is it clear? The way the behaving of the blocking and non-blocking is slightly different. You should know that when to use the blocking and when to use the non-blocking. The recommended to for modeling the digital circuit is blocking. You can go with what? Combinational blocking model, sequential non-blocking. Now let us see some rules to be followed. What is the rules to be followed is, I think one rule I said already. For combinational logic, what modeling you can use? What model you can use? Blocking assignment. For sequential, you can go with non-blocking. So it is recommended that, say, suppose in one procedural blocks, always an initial block, it is not recommended to use both the blocking and the non-blocking. That we call a mixed blocking. Did you understand? If one statement you can use blocking statement, one procedural block, in another procedural block, you can use the non-blocking. That model of styling is acceptable. What is not acceptable means, in the same procedural block, what is procedural block is? Initial or always. The same procedural block, mixed modeling. Mixed blocking means what? Blocking and non-blocking assignments are not mixed in the same block. Always. Did you understand? This is one rule you should follow that. So it is recommended that blocking and non-blocking assignments are not mixed in the same always block. Always block. Okay. So simulator may allow. If you are using simulator may allow, but this is not a good design practice. For the good design practice, designing, modeling the hardware, what you should do? Don't allow mixing the blocking and non-blocking in the same model. Procedural statements, always block. You can use in the one always block, you can use what? Blocking. Another procedural block, you can use what? Non-blocking. That is a good practice. So this is one rule you should remember. And then, so Verilog synthesizer ignores delay specified in the procedural assignment statements. We already know that whatever the delays we are specifying for what our synthesis, simulation purpose, that will be not always what? Synthesizable. The second rule means the synthesizer ignores the delay specified in the procedural assignments statement, that is blocking and non-blocking. Whatever the delays you are specifying to your blocking and non-blocking will not be what? Synthesizable. This is for what purpose? Only simulation purpose, not for the what? Synthesis purpose. Delay is specified to the blocking and non-blocking to what? For the understanding, for the simulation purpose. And may leads to the functional mismatch between the design model and the synthesized netlist. If you specifying the delay, may leads to mismatching between the design model and the synthesizing of the netlist. So a variable can appear as a target of both the blocking and non-blocking assignments. You can see this is not what? Permittable. What it is not permittable here? So what expressions I am taking? This is equal to x plus 2. Then what I am doing? X is the non-blocking, less than or equal to y. Means the variable cannot appear as a target for what? Both for blocking and non-blocking assignment. So this is not permissible to use. So this is, first is x is equal to x plus y. Next is x is less than or equal to y. So these rules you can remember when you are working with what? Blocking model and non-blocking. And still we need to discuss few more things about blocking and non-blocking. So we will continue with the next session. The next session we'll see some examples of modeling using blocking and non-blocking assignment. What is the objective to get the feel? Good type of using the assignment statement for the good design file. Getting the design file for the particular scenario. We'll see that. And we'll see that how to avoid some non-good design practices using the blocking and the non-blocking assignments. Did you understand this? Because when you talk about behavioral model depends on this. Correct. Your procedural statements. What are the two procedural statements? Initial and always. Initial and always you will be writing the sequential statements. The sequential statements you can write in two ways. One is blocking and non-blocking. So if you have a good idea about blocking and non-blocking, modeling of any digital circuit behavioral model is quite
ये मैं
easy.
कह रहा हूँ कि
You are struggling to understand this how the way it is behaving, blocking and non-blocking. And modeling of behavioral model is quite difficult. Okay. So today what I can request all of you, I will be sharing you this PPT. Anyway, code is I have given here. Okay. You write the design file if it is required. Then you write the test bench. Understand how blocking will work and non-blocking will work. Okay, I think all these programs, you know how to write the test bench. Correct, how to write the model, definition, test bench. You exercise this. Are you clear? And the next session will go with these other things. Few more examples of blocking and non-blocking. So then we'll go for timing. Is it clear? So with this, like we stop the session here. So we will continue in the next session. So I request all of you to fill the attendance. Online student, you can fill the attendance now.
हाँ आप एक काम करना ग्राउंड पर आ जाना मैं आपको कॉल कर दूँगा हाँ क्योंकि मेरा घर रोड पर ही है
Now let us take this example. How this will be scheduled.
कॉल कर देना ऑफिस में आके मैं आपको रोड पर ही कर कहीं जाने की जरूरत नहीं सीधा रोड पर मेन रोड पर ही कर देना
Can you see this example?
हेलो
This is always the initial begin always at the rate A or B or C or D. Begin always initial begin. Yes, this is a correct way to representing the model. When you are writing always at the rate event. So this is a events, right? C is writing here, B or C or D or E. You be giving a body to this, right? Now what happens if I am writing this always block having only single step. But we are not writing the model for this events. Correct? This is not a good practice of writing the code. If I am forget about this line, if coming to this initial, how this blocking statement will exist. This is starting at what? Time t is equal to 0. This is also starting at what? Time t is equal to 0. So both are started at time t is equal to 0. What it is going to assign here? This is scheduled at C will schedule at what? 5. Correct? Then it will do the XR. Talking about XR operations. D value will be takes an operation. Again at this up 10 because it is a blocking step. Once this is executed, then it goes what? This one, right? 10 at 10, whatever we get is PLC. Next, what it is going to schedule here? This is at 5. Again, this is at 10. Then what happens? At 20, B is equal to what? C plus C. Again, next what happens at 35, A is equal to what? T plus C. Did you understand?
Sir, your screen is not visible, sir.
Uh-huh.
Sir, screen is
If I
not.
use? Okay. Now, this is an example I'm taking. This initial block, there are two initial blocks are there. These are scheduling at time t is equal to 0. These also start. These are procedural blocks will concurrently execute. T0, T0. But which one will execute first in this case? Fine. Now this will be scheduling at t is equal to 5. At t is equal to 5, what happens? D XR of 2, XR of since repeating statement. Next it is going to execute subsequent, which is after this, what is next? But 5 plus 5 means what? 10. At 10, E is equal to C plus D. Next what happens? Now it is 10, simulation is happening. Next what it will happen? 10 plus 10 is 20. At 20, B is equal to C plus D. Now this will be scheduled at what time? 20 plus 15 means 35. At 35, D is equal to, A is equal to B plus C. So this is at 5. These are sequentially it is executing. Okay, this first okay. One second. See this code, this will execute. This also time t0, this also time t0. Correct. Let me don't. Let's copy this. This is also executing at what time? T is equal to 0. This is also executing at what time? T is equal to 0. Now all these are, what blocks these are? Blocking assignments these are. The sequential assignments are in blocking assignments. Now it is scheduled what time? This is scheduled at what? 5. Okay, because I have specified the delay here. Simulation time. Now first this will be executed. When this will be executed? Before this preceding statement should be executed. Now this will be evaluating at what time? T is equal to 10. Correct. Now what is the next statement it is going to execute? When the next statement will be executed? Is it A will be executed or B will be executed? So A will be executed. Because it is a
Hello.
sequential execution,
Hello.
right? It is sequential execution.
हाँ अंकल हेलो.
Correct. It is sequential execution.
अंकल क्या हो?
Now A will be executed. Now what is the A value is nothing but
अच्छा आज
10 plus 15.
4 बजे शाम को गाड़ी देगी.
at t is equal to 25.
हाँ तो आज
Sure.
No, this will be executed here. This will be executed at, this will be executed at t is equal to 15, not 20. You are correct. This is executing at t is equal to 15. Because these are two initial blocks. Correct. Because when this is executing, this will not block in another procedural statements. Correct. In the blocking statements. Now this will be scheduled at what time? At t is equal to 25. Correct. Because both are started executing at what time? At time t is equal to 0. Is it clear now? This is scheduled at t is equal to 5 time. Now this is scheduled at t is equal to 15. This is scheduled at t is equal to 8. You can try this, run this program today. Okay. You try and see the simulation result of this blocking statements. Okay. So let me continue with few more examples of blocking and non-blocking. Okay, what is a good practice when to use the blocking and non-blocking? Few more examples we'll see tomorrow.